So, hello guys, welcome to our next video in the playlist Google Earth Engine for the beginners. So, in today's video, we are gonna learn how to write an function for our own use. So, instead of the built-in functions by the Google Earth Engine API, we'll build our own function and we'll also specify what are the inputs needed and what will be the return of the function and how we can apply them to an entire image collection consisting of the number of images of particular function. So let's start with importing our Sentinel-2 dataset. So I'm searching Sentinel. I'm importing harmonized collection for the level 2A. So I'll tell one more thing. What's the difference between this level 1C and level 2A is that it's just the processing levels. The level 1C is processed at first level, and the level 2A has been processed in a more advanced way. The level 1C will be considered as a top of atmosphere reflectance. So where they have been not been corrected for the atmospheric corrections or the reflectances, but the level 2A are the surface reflectance values. So it's better always to go for the higher level of satellite imagery collections if it is available freely. So let's import this image collection. Let's say denote as S2. I'm also defining my region of interest. Let's search for Mysore, and I'm locating and add a mark tool in order to define my region of interest. I will rename it as ROI, which stands for region of interest. So now I will create one more variable called filtered image or the filtered image collection, whatever you can say. And I'm selecting this S2 Sentinel data collection. I'm filtering it to my region of interest with the help of the filter called dot filter bounds. So it should filter it down to region of interest, and I should also filter it down to the latest date. Let's say with the help of filter date function, I am using it to January 2024 to let's say December 10. Okay, so let's print this out in order to know how many collections are available for these two filters. So I'm printing the filtered image collection, paste it in here, just run. So you can always use the control and enter button in order to run any script. So I have 92 elements available. So I have to now also filter the clouds. I will use the dataset. I will use the function e.filter boolean function less than, and I should also paste my cloudy pixel percentage. You can go to the Sentinel-2 dataset, and if you go to the image properties, here I have one property called cloudy pixel percentage, which specify how much is the cloud cover for single image. So it's this property is there for every image. So my cloudy pixel percentage should be less than say 0.1%. So let's filter this out. So here you can see I have three elements which have uh, cloudy pixel percentage of less than 0.1%. So if you can just go to the properties or the features, and I will check on the first image. Here you'll see the property, scroll down to cloudy pixel percentage, it is 0.02. So that's okay to work with. So now we'll create a function in order to apply the scaling factor for the Sentinel-2 data collection. So in order to just know more, we will click on our Sentinel-2 collection, and if you just go to the bands, here you will see the name of the bands and the list, the aerosol B1 for B1 and B2 blue, B3 green, like that. So if you just slide it to right hand side, you will also get the resolution and wavelength of the each band in which our reflectance have been recorded, and you will also get the scale value. So the scale value for each band is 0.0001, which specify that whatever the values are there in each band, it has to be multiplied by the scale value. So why the Sentinel instrument or the dataset providers do like that? Because in order to store an integer value and then uh, float value, there will be differences in the storage capacities. So it will be always easier to or require a less storage in order to store an integer data set as compared to an float data set. So if you can, I will show the difference between both of them. So let me add this filtered image to our map in order to know how the difference between the scaled image and the not scaled image will appear. So I am applying the filtered collection. Let's say I have to I have to give we define the visualization parameters later. So I am just adding the filtered image to the map. So if you can just zoom in, you will see a black image, but I'm getting some image, but you are not able to see any of the features on the earth. So I will just now change the parameters to the true color composite with the help of band combination. In the red, green and blue channel, I'm using red, green and blue only in order to have the true color composite. So if you can stretch the range of the reflectances, here you will see the data set we have ranging from 0 to 2895. So typically all the images with the reflectance will usually have an image reflectances value ranging from 0 to 0.3. So here we are getting more near to 3000. That's because we have not yet multiplied the scale. If we multiply by the scale value of 0.001, we will get to our original reflectances value. So here you can also select the first image in order to know the clearly difference. So I'm using the dot first function in order to get a clear visualization. So or else let it be like that only, because it will be easier to compare after scaling. So I'm switching back to the composite. Yeah. So now I will create a function called scaling function. I will just call this variable as scaling, and I will create a function with the use of a function, and I will take image as my input. So you please understand, we are creating a function which I have written inside the brackets are the inputs. It means whatever the functions will do will now do for this input image. So now I have to tell the function what you have to do. So I'm telling the function that you take please and take input an image, and you return an image by multiplying the scale value. So I'm using dot multiply function 0.0001, and you just return this with the help of the input image. So that's it guys, our function is ready now. This is a simple function. If you can learn more, you will get to know the complex functions, how does it work. So now I am creating one more variable called scale image, and I am applying our function called scaling to our filtered image collection. So if you can just copy this filtered image and use the function called dot map. So this function, what it will do means it will apply whatever the function I will give to all the images which are present in this image collection of filtered image. So we can check on the dictionary if you want. So if you can come to the docs, you search for map. So yeah, here we are reading the library, the description of a function map which takes input an algorithm, and it maps an algorithm over collection, that is the returns the mapped collection. So we need to specify what is the collection is, and what's the function we are using. That's it. So rest of the drop nulls, the boolean functions are optional. So remember, what are the arguments which are given in the italics will always be optional. So if you can leave it as it is, it will take the default value. So now I have applied our scaling function to our filtered image collection, and let's add this to map in order to know the difference between our filtered image collection before scaling and after scaling. So you can just rename it as scaled image, and here I am renaming it as prescale. It means before scaling. Let's give it a run now. So you can uncheck this geometry. So we have the two layers. Let's stretch those values. So first I'm going to my pre-scaled image. This we have seen earlier. You stretch the range to 100%. You can still see the range is between 0 to 2000. So let's switch it to the true color composite with the help of RGB channel and apply it. Okay. So this is the pre-scaled image. Now let's do the same for our scaled image. 4, 3, 2, and stretch the range to 100%. So here now you can see our range has been changed from 0 to 0.28. So it's nearly 0.3. It means our scaling has worked. The values has been replaced or multiplied by 0.001, which is the scaling value. So if you can just see, both the images looks more or similar, but their reflectances are different. So I am using the inspector column. So here you will see the range of the pre-scaled mosaic ranges from 8 to 3000, and our scaled image are still in point 1, point 2, point 3. So if you have little bit knowledge on what the reflectances are and how the reflectances will work, what will be its range, you will have an idea about this scale fraction. So this is usually a normal function which is used to apply over a range of images which are present in our image collection. So we have multiplied the scale value in this particular function. So we can also add one more function. Let's say I want to add an NDVI to our map layer for the image collection. So before doing that, let's print this. Let's print our scaled image. So we can just come to console, and here you'll see we have three bands.